When I was a student, in fact, when I was at high school, we had to do analytical chemistry trying to identify different ions like bromide, iodide, chloride, and we did all sorts of tests. So I thought it'd be quite fun to get Sam to do one of these tests. These tests look really quite pretty, though when I was a schoolboy I found them really tedious. It involves adding silver nitrate to the solutions and you get a precipitate. When you add the silver nitrate, you get silver ions in the solution, which also contains nitrate, because you put in silver nitrate, but also chloride or bromide or iodide ions. The silver halides are very insoluble, so when the silver and the halide ions meet, they form a solid and precipitate. So there is quite a nice reaction, and you get a precipitate of different colours depending which halogen you use. So as a test, although I didn't mention this to Sam, she decided she would use fluoride as well. That's all 4 halogens that you can get easily. Astatine and the new one, tennessine, aren't really available to do lab experiments. Silver ions with fluoride was a bit disappointing. Silver fluoride is reasonably soluble in water, so you don't form a precipitate. With silver chloride, you get a fairly white precipitate. And these precipitation reactions take place incredibly fast, much faster than your eye can follow. This is not something that gradually develops. 1 minute it's clear, the next minute, boom! Silver bromide is pale yellow, and silver iodide is rather more yellow. Now, why am I telling you about these compounds? And the reason is that these silver halides have been technologically very important, particularly silver bromide, because silver bromide was the material that was used for old-fashioned photographic film. Nowadays, everybody takes digital pictures, but until really quite recently, most photographs were taken on film, and the film has a layer of silver bromide crystals, very small ones. And the amazing thing about silver bromide crystals is that when they absorb light, they are dissociated, so you get silver metal formed. You don't get very much silver metal formed, but then when you put it into developing solution, that tiny piece of silver acts as a catalyst and bigger particles grow to give you the black colour and black and white film. I hope one day we will be able to show you in a dark room the chemistry of film, but this compound that's sitting in the test tube is the basis of all photographic film. There is one quite funny question which people sometimes ask, which is, what is the colour of unexposed photographic film? That is, film which has not been exposed to light. Because if you want to know the colour of something, you have to shine light on it. And if you shine light on it, the film has been exposed. So nobody really knows what the colour of unexposed film is. And silver iodide crystals have a really unexpected application, which is to make rain. In the sky, there is a lot of water vapour, and the water vapour can condense to form clouds, and the clouds produce rain. The problem is that water vapour has to be cooled to a very low temperature before it will spontaneously form crystals of ice. But if there are tiny particles in the air, this acts as a nucleus, and the water droplets or ice particles can form round them. Shortly after the Second World War, about 70 years ago, it was suddenly realised that the structure of the crystals of silver iodide have the same sort of spacing of the atoms as in crystals of ice. So people had the idea of injecting very fine powders of silver iodide into the air where clouds were forming to make them form thicker clouds and therefore to rain. And it works, but nobody quite knows how. And most recently, people have done experiments and show that ice doesn't form in the way that people thought. And so the spacing of the atoms on the silver iodide is not the relevant property, but it still seems to work. And so in many countries now, people use silver iodide for seeding clouds. There are two reasons for seeding clouds. One reason is to make it rain, to make your plants grow better. The other reason is to get the clouds to start producing rain before a real storm starts. If you don't seed the clouds, then they build up and up and up, and then suddenly start producing large hailstones which can cause enormous damage, smashing buildings, denting cars, and so on. So silver iodide can reduce, or people believe that it can reduce the force of a storm and cause less damage underneath.
This paper to one side.
Yep.
In fact, before we do that, I want to take a selfie with it. This is me and the first paper to describe like photos properly. You liking that?
Got it, yep. Mm-hmm. They range in price depending on what the scene is, so its artistic value, from around £10,000 to the most expensive print in this box has been valued at £500,000 for one photograph.
£500,000?